Greetings everyone, I myself Sravani Sharma, pursuing Masters in Construction Engineering Project Management at CEPT University. I am holding the student code PCM24384. Now let me present my portfolio of my Studios 2, that is Construction Project Execution Monitoring and Control, which is part of MCM program at CEPT University. This studio mainly focuses on learning tools and strategies used in managing complex construction projects. The project of mine was high-rise residential project, which was further divided into many around high-rise luxurious residential development, an iconic 131-meter structure with 3 towers and 1 or 2 executive residences. Now let me quickly dive into the details for the project details. Diving into details, the project briefs around like an iconic luxurious residential complex with 3 towers, 37 stories above the ground level and 3 basements in the below ground level. It is a greenfield project. It is a crucial preparatory tasks carried out before an actual construction begins. Being a greenfield residential project with an investment of 188.5 crores, it requires meticulous planning and statutory clearances. The prime contractor is responsible for the core and shell work, MEPF installations and finishing tasks under an item rate contract. We also see work distribution around currently around 187 laborers on site with a peak capacity of 220. We can also see the coordination among the stakeholders like design consultants like clients, architects, site engineers and contractors, way seamless mobilization. Coming to the pre-construction activities, we have pre-construction meeting, safety control measures, execution sequence, site mobilization plan, staff requirement, and equipment and tools approval, legal, time, and cost. So coming to the site mobilization sequence, we have the mobilization planning. Next is the site survey and the preparation, and setting up the office and the labor colony, and then we go for the setting up the material storage department, and then the equipment mobilization. So for the pre-construction meeting, we have the stakeholders like architects, site engineers, contractors, subcontractors, and clients. And in the pre-construction activities, we actually plan for the requirement of the water and electricity on site and the labor colony. So we have around the quantity, the main sources from the borewell and the water storage tank. The basic machinery used for the electricity consumption was mainly of tower crane, bar bending machine, bar cutting machine, bar threading machine, borewell motor, and other from the non-tower areas. Apart from this, the number of staffs in the on the site are project manager, HR, quality department, that is quality head and the engineer, and planning and billing department and store department. Around 220 laborers we have. So next is the under pre-construction activities, we have the legal approvals, that is from the responsibilities of client and contractor. So further continuation for the pre-construction activities mainly focuses on the safety control measures and the equipment mobilization on site. Proper safety protocols are essential, especially for the high-rise construction. Toolbox stocks, PPE kits, barricades and soft barricade and hard barricade, and safety boards were mandatory measures implemented on site. It also lists the major equipment used like tower cranes, bar bending machines necessary for the vertical construction, as we know. This reinforces that pre-construction safety planning is not just a compliance task but a foundation for the effective execution throughout the project lifestyle. We dive into the quality control that especially through tools of qualities that we have compressive strength monitoring for M35 grade concrete. Control charts were prepared using 7-day and 28-day strength data as per IS code 456 is to 2. These charts helped to identify the variability in mix quality and confirm if the strength parameters align with the IS specifications. M35 concrete was mainly used for casting shear walls and columns across key structural levels from first level slab to the 16th level. So maintaining its quality was non-negotiable. Preparing such control charts not only enhances quality assurance but also ensures long-term structural performance. Here we shift attention towards the identifying the and mitigating non-conformances during construction. Using histograms and Ishikawa fishbone diagram, we explored the root causes of quality lapse ranging from the poor mix design and compaction techniques to lack of skilled labor. The consequences of NCs such as water leakage, compromised aesthetics and cost overruns make early detection critical. Preventive measures like better foam work practices, skilled supervision, and standardized vibration techniques were suggested to ensure the consistency. Coming to the value stream mapping, it is one of the most insightful tools applied for the lean construction. Here, the current state of shuttering of work for the shear walls was analyzed with a cycle time of 10.89 minutes per square meter. So, above targeted time would be calculated was 6.75 minutes. It was clear that the inefficiencies existed, but we mitigate the non-value MUDA 1 and MUDA 2. The current state map also revealed a total lead time of 424.55 minutes, out of which only 181 minutes added real value. This mapping made it easier to pinpoint delays and understand where lean strategies could make the most impact. Building on the insights from the current state map, lean tools such as 5S, Kaizen, Kanban, and Gemba Walks were introduced to streamline operations. This slide shows the resulting future state map where the total lead time dropped to 267.4 minutes and value adding time increased to 163.4 minutes. Non-value adding time was reduced by eliminating redundancies like tool searching and miscommunication. The takt time comparison highlighted the success of these changes in aligning actual work with project goals, thus boosting overall efficiency. We have also used work sampling, which was the another technique used to analyze on-site workflows. On day one, activities were observed across multiple floors, that is from second level to the fourth level, including shuttering, reinforcement, casting, and block work activities. These were observed and categorized into four types of activities: D1, C1, A1, and B1. This is the spaghetti diagram tracked the movement of patterns of the worker and the resources of the pathway. It was clear from the observation that multiple overlaps and unnecessary travel paths slow down the productivity. These insights became a baseline for the proposing future improvements. Continuing the work sampling analysis, comparing time distribution on day 1 and day 2, interestingly, day 2 saw better concentration on core activities with 67% of time spent in a single task compared to 59% on day 1. The drop in secondary task time suggests improved planning and flow. Such comparative analysis not only helps understand daily performance trends but also aids in short term scheduling and micro level workforce management. Coming to my key learnings, the portfolio highlights the importance of integrating the lean tools, quality management practices in a high-risk residential projects. Apart from this, pre-construction activities from where we mobilized from mobilization and quality checks to lean mapping and work sampling. Each layer of analysis helped reveal insights into efficiency, coordination, and control. Personally, the studio helped me to develop a systems thinking approach to construction management. I learned that every delay, every rework, and every miscommunication on site is not just a task level error but a systematic inefficiency that can be addressed through structured tools. I look forward to applying these learnings in real world projects, making construction not just faster and safer but smarter and more value driven. Thank you.